Alright, so I was going to do a demonstration of this pathfinding algorithm that I've been working on for the ground team. It's so basically what it does is it takes a ROS occupancy grid and it tries to find a path through it. And so an occupancy grid in ROS is basically just a grayscale image. So it's just an array of integers, and they have a value of 0 to 100, not 0 to 255. And so you have to remember that. But in this case, the occupancy grid is just set up so that 0 indicates, or -1 indicates vacancy, or no, -1 indicates if it's known whether or not it's vacant. But in this case, our map is 0 for vacant or 100 for occupied. So it's just basically one or the other in this case. But in the real world, you could have it set to -1, which would mean that it doesn't really know. So that's something to consider. But in this case, it's just either occupied or not. And I got a program that will open up a bitmap and essentially publish it to ROS so that you can test stuff. Here it is. And so this is like a test map. And the algorithm is visualized in RViz. Yeah, so this is it. You can set goal points. Let me change the scale here. You can set the goal point, or the goal point is the green point and the start point is the red point. And you just run it. Alright, let's see here. So that's the path I found. And this is where the algorithm goes to visit. So all the dark areas are where it's searching. And it's using the A star path finding algorithm. So essentially it's just it's A star, but it's just a grid which is each pixel is a node and it has 4 neighbors. And so this is multi-threaded, so there's actually 2 threads that run. So it's, you have one thread that starts here and is searching towards the goal, and then you have another thread which is starting from the goal and searching towards the start. And the way it works is eventually, or if it's tuned properly, these 2 search spaces will collide, and wherever that collision happens is where, there we go. This is like, so the blue point's where the collision happened. So see, in this case, goal point collided. So the goal point hit the start thread, and the start thread was down here screwing around trying to get here. And so what happens is when this thread hits the other thread, it halts both threads, and then the path is reconstructed such that, like, from this point it follows each node's parent to build a path that way, and then the index of where this collision has happened is passed back to the reduction part, and it selects this node from the start node's space, and then it goes back. So in the end, you just have this path. Let me scale that back up. And so what's happening right now is I have this selected, this flood grid thing, and there's a heuristic that I'm using which is supposed to make it so that the path is not doing this. So it's not supposed to be right up there against the edge, and without the heuristic the path would be right up here against the wall because it's searching for the shortest distance. So what the heuristic is supposed to do is to first and foremost reduce the amount of space that the algorithm searches, and secondly, to make it so that the path, it's kind of like it should go through the center of this. There we go. So yeah, so it just keeps it spaced away from the wall, so your robot wouldn't like, hit stuff. And it takes a long time to calculate the heuristic for the entire image, so that's why it actually just only calculates it for the nodes that it visits. And the reason I have that checkbox there is so that I can show what it would look like if it were to be calculated for everything, which is like this. And so the heuristic is, I call it the clear path heuristic. It's pretty simple. It's just like at each point it performs a little routine where it figures out how far away is the closest obstacle. So you can visualize it like if you would first check a small radius, and then you would increase the radius, checking the nodes until you hit something, and then you return how far away it is. So this is what it looks like. Uh, you can see that the closer you get to obstacles, the redder it gets. And anyways, the algorithm is searching for the shortest distance overall, while it's also trying to kind of stay in the blue area, we're supposed to be anyways. And this also has the effect of reducing how much of the possible space it has to search. So like you can see like here, like the go point collides with the start thread space at this blue point. And when the go point hit this, the start thread was down here searching for a path, because you have to think about it, like there might not be, or there may be a big gap right here that's a better path. I mean, the algorithm doesn't know, so it's down here searching, and but while it's doing that, I'm not sure why it's doing this right here. Like it's got these little tendrils coming off of it. It must just be a result of the rules that I'm using, but anyways, it's not searching this whole space, which would take forever, because without the heuristic, it was taking like 150 seconds to calculate everything, and it was ridiculous. But as far as the speed, when you turn this off so it's not calculating the entire map, let's run it again. So that took 10 seconds, but it only took like maybe, I don't know, that was like a second for the actual algorithm. Most of that time was just spent copying memory over, and I may be able to share that memory and optimize that so it doesn't have to happen. So if that was the case, then it wouldn't take long at all. But I also have the ability to scale the image, so I could scale the map down to say like a 4. And you see like it's kind of goes a little 8-bit. Let me redo this. Fix that artifact. There we go. Because I had to have that because like it was taking like 2 or 3 minutes to solve. But now that I got the heuristic kind of tuned up a little bit better, I can just use the original scale. And so right now it's copying the space. Now it started searching, it's done searching. Now it's doing the flood grid. See, this takes forever. If you was to calculate the heuristic for the cost heuristic for the entire map, it takes a while. Oh, that's interesting. Wonder what happened there. Oh, here we go. Oh, that's pretty much it. I just wanted to share that with y'all. Gotta take it easy. Where's it at?